Hello guys, welcome back to Aerospace Trainings. Today we are going to see the topic 8 of Creo Parametric, creating patterns. Okay, so as you are seeing, this is a circular pattern. Okay, if you choose a source element that is a part of another pattern, the element will be automatically extruded from the new pattern. The new pattern will not reference the initial source element. If feature shares a common face, you must select them in the order that they were created. So the common face is created before a second feature is copied. Okay. You cannot select parts that are within an active configuration as elements of patterns. To understand configurations, see configurations overview. Now see, this is also circular pattern, advanced patterns. You must have all of you actually have seen this pattern in a lot of things like household things, daily day-to-day life use things. Mirroring selected features, mirroring all features, and creating mirror parts. There are two types of patterns like means geometrical pattern and single pattern also, in which the rectangular pattern and circular pattern is also used. The second aspect of this session is measuring and inspecting models. Okay, so it's kind of a theoretical part, and you use this for measuring and inspection in Creo. The inspection module allows inspection information in the form of a measurement plan to be attached to the Creo elements direct modeling model. This measurement plan can then be exported as a comma separated file. That's what we call a CSV file. This is the long form comma separated file to allow inspection data to be entered into it. This CSV file can then be re-imported into Creo elements direct modeling to perform an evaluation on the design based model. Okay. Now, what is the flow? The process flow, then the preparing in the measurement plan, then once prepared, then validating the measurement plan, and once validated, export the measurement plan. For user task information about this module, see using the inspection module. This is the process flow actually, which is followed. See, these are the guidelines. Exporting the measurement plan. Index group means inspection taught, result, comment type, nominal, upper tool, lower tool, SD data. Now, validating the measurement plan. Once the measurement plan has been prepared, it should be validated before being exported. Validation verifies that the specified measurement plan still makes sense for the current state of the design model. For example, validation checks that the measurement points still lie on the specified face and annotations referenced in the plan are still meaningful. A plan is valid if all measurement annotations in the group have the same owner, but may have different document planes. Okay, there are no measurement annotations with unassigned measurement points. Also, all measurement points lie on the faces associated with the annotation, which may not be the case if a design change has made previously defined point invalid. Normally, the inspection engineer should not be allowed to make geometrical changes to the design model. If validation fails, the system displays the error information in a browser window. In the case of inspection engineer needs to update the measurement points to be consistent with the current design before an external file can be generated. Basically, it's kind of a theoretical aspect, and you need to understand why measurement plans and validating the plans and inspection of the plans. Let's see the rectangular and circular array. Go to new, create one part. Let's create extruded part and sketch view. Let's draw one rectangle. Click OK. Adjust the height. I think this is okay. Now click on OK. Now just create a hole here. See, placement. Click on this surface. Diameter is too big. Let's make it less. Chain is also okay. Let's make it 20. Through and through hole. It's a linear hole. No issue with that. We need to place this for the references. Distance is one there, and okay. Now click OK. See, the hole is placed there. Now you can go from here also, and from this extrusion here also. See, from the model tree, you can click on the extrude which you created. You can go here also. Otherwise, you can go here also. See, pattern and geometry pattern. So we'll go from this See pattern. Wait a sec. See pattern. Okay. Dimension, direction, axis, field, table. So let's create by dimension only. Okay. So direction. Let's click on SH. Five or 10 or whatever you need. Spacing between them, you can change that also. Make it 30. Okay. From here you can change the direction. This is the rectangular array actually. Now second direction, select one edge, number make it 5, and distance make it 30. You can flip this direction also. Let's do this one and click on OK. See, it's regenerated now. You can see this. All the holes have been patterned in a rectangular way. Now let's see a circular one. Now, so let's select the surface and go for sketch. Make it a sketch view. Let's draw one small circle here. Yeah, this much is okay. Click on OK. Extrude this. Give it some height. No, okay. This much is okay. Click on OK. Now draw one circle over on this surface also. Wait. Yeah, draw it here. Okay. Now extrude it. We want to remove the material, so just flip the direction until when we can select the options here. See, extrude up to next surface. Otherwise, extrude to intersect with all the surfaces. Extrude to the selected surface. See, we can do this also. Click on OK. Now see, the hole has been made till this rectangular surface. Okay. Now we want to do pattern of this one, right? So click on extrude pattern here. See, now here we can select the axis pattern. Now in the dimensions, see, we have clicked it, selected it. See, we need to give the direction. So first of all, let's select the axis. See, number of members 4. You can change it, or now angle. If you don't want to give the angle to it, just click on this option. That means in whatever number you have given, divide it in 360. Okay, so like this, you can see I will increase number of instances. Let's give 10. You can see now. Just click on OK. See, it's generated. So we have successfully created the circular pattern also. You can see this is the rectangular pattern, this is the circular pattern. It's just like array in AutoCAD. Okay, so yeah, now let's see some measurement and inspection tools. Now whatever we read about actually in measurement and inspection tools in the sessions theoretical part. Let's see that. So what we'll do, we'll create one geometry. Let's extrude something here. Sketch view, draw one rectangle, click OK. It's too much big. Just, yeah, that's okay. Click OK. Now draw two circles over here. sketch view, circles, one is here, one is here. Okay, now click OK, extrude both of them, just remove the material. Okay, now see here in analysis you can actually check this measure. Here also model report, you can check the mass properties. In this measure, see summary, length, distance, angle, diameter, area, volume, transform, all of these aspects you can actually measure. This summary, click on this surface, see area is given, perimeter is given, external perimeter is given. Otherwise click on this circle, curve length and all those things. Here also the same thing is open here actually. Okay, it's a pop-up menu. Length, so for length actually now I have clicked length, so this surface to this surface, see you can choose from anything actually, from this edge to this edge, you can see it, right? So actually by choosing one by one from this, you can measure actually anything, area, diameter, angle. See, I have clicked on area, I clicked on this, it has given me the area in inch square because we have set it in inch, right? Diameter, I want this circle's diameter, see it's giving us wherever we are selecting. So these are the actually measuring tools in this. Okay, now in the sketch part, see let's go to sketch for once. Okay, click on this surface, wait, first of all cut this, click, now go to sketch. See in the sketch there are some inspection tools also, like intersection point, tangent point, entity, right? Let's create it from a new one. Let's close this, go for a new file. Okay, now go to sketch, select the plane, click OK, make it normal. Now see dimension, constraint, feature requirements, overlapping geometry, highlight open ends, shape, shade, closed loops. Like means if you are drawn rectangle, see this closed loop is given. If I close this, it's not showing, right? Now see what it's saying, it's overlapping geometry. Like see, if you draw a circle here, 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 click on OK. Now first of all let's hide the dimensions first. Go to options, picture, line thickness, let's increase it up to 3. Okay, click on OK. Okay, it's too many pieces. Now pressing shift and this, you can pan this. Now see it's off actually. When I click this on, it highlights what? It highlights this section only, whatever the intersection point is, like overlapping geometry. This all circles are overlapping each other, that's why it's highlighting it. Okay, now highlight open ends. Now see if I draw a geometry like this, 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 and now see it looks like it's a closed object, right? But for convert it into 3D, it actually it actually should be closed, right? Now what this says highlight open ends. Now see, I have clicked this. First it was off, but when I click it, you can see here it's showing us the red. Wait 1 second. Let's off all this for a sec. Yeah, now you can see better. Like when you, it looks like it's a closed object, but when you on this, it shows us that it's an open end. Now you can use this corner tool and click on these two lines. That's it. Now it's not showing it. See, so it's a very means basic. Now intersection point, tangency point, EDD. These are some inspection features for sketching. There are also some inspection features for the in the model section which we can use for development of plan, for validating the plan and all that. So we will discuss it in the coming sessions. For now, this is enough. Okay, I hope you understand the measurement and inspection tools also, and the circular and rectangular patterns that we have seen. Okay, let's meet in next session.